looks like it's moving. And then the role of CT in attenuation. What problems might you have? You know, there are multiple things in a CT scan that equate to attenuation that we have to think about. Poly versus monogenic beam, or radiation beam versus beam. Increased attenuation via Compton photoelectric with CT. Energy can't be the same no matter what you do. And then the concept of segmentation, of trying to segment the attenuation coefficients based on the stuff that the CT is going through. So high attenuation objects are going to add or take away PET gamma rays, or photons. High attenuation, patients got metal in their mouth, and you do a PET scan, and you do CT correction for attenuation. So what's the CT scan going to tell the PET picture to do? Add or take away photons?
Take away.
Add.
One of you's right.
So high attenuation, like a metal, is going to absorb.
So if CT has high attenuation, think of it from this perspective. CT has identified something high attenuation, and you've got radiation coming out of the area that's highly attenuated, then there's going to be less photons or more photons coming out?
Less photons.
Less photons, right. So less photons, so CT is going to tell PET to do what? To add, right? And versus air, if you got air, as a good example in the lungs, you got X gamma rays coming out, and CT is going to say, oh, that's air, so there's less attenuation, so you need to do what to the photons? Add or subtract? Subtract, right? Take away because there's less attenuation, add if there's more. And then we know from there, if you've got metal, or if you've got rings, or if you've got anything of that nature as a general rule, the CT is going to add counts. Contrast, it's going to add counts, and it's going to perhaps cause a false positive. So you have to look at the attenuated image versus the non-attenuated image, essentially. The one example, what's the one example that has higher density but does not have any correction with attenuation? Do you remember that example? It was some kind of artifact that was in the patient. Huh? No? No? Something in the patient. And you would normally think, gee whiz, if I follow that theory, then there ought to be more gamma rays there, but they're not. Or more photons there.
The fake hip.
Fake hip, right. Because in a prosthesis, there's no uptake of FDG. So even though it's dense, and normally then the CT is probably saying, okay, let's add photons, since there's 0 photons coming there, and it's saying add whatever volume, or not add, multiply X amount of photons based on the what's coming out. It's going to 0 times any correction is going to be 0, right? So it's going to remain cool. The last part of this exam will be on DAT scan. And on DAT scan we have, remember PD versus PS? PD is Parkinson's disease and PS is syndrome. So again, it's Parkinson's. How does PD affect the brain with up and down regulation? So do you remember what causes Parkinson? An increase or decrease in dopamine. It's either one of two things. Either dopamine receptors are not producing enough, or we don't have enough receptor sites. So which one is it?
What is the decrease?
What's decreased? The receptor sites or the dopamine production?
Both.
Nah.
Should be the sites.
Huh?
The sites?
It should be the site. Ah.
The production.
Very good. Very good. Okay. You know why I remember that? Because in one of the slides it says the problem occurs at the presynapse. So if you can remember the word presynapse, that's where the loss of dopamine production occurs, which means that what the body is going to do is it's going to, I want to say, upregulate the receptor sites, because then there's also upregulation and downregulation. I'm not sure if I'm.
Right, so for the up and down regulation, if we have more dopamine coming out, then we're gonna have upregulation, right? Like
You would
more
want it
receptors.
Down regulation, because the body's going to reduce. Let me go look at that, make sure I'm
This is
right on that one.
confusing.
I think I'm right on that, but
Because
I
you don't have
could be
enough
wrong.
receptor sites for all those receptors, so you have to down-regulate so that not enough receptors.
Don't regulate what at the base, like the secretion. I don't know, we'll see. I always get confused.
Oh wow, it's already up there. That's so loud. Alright, so if we go over here, where is GE Study Healthcare? No, that's not it, is it? I don't think so. GE Healthcare Atlas Study. Oh, it is it. Okay, cool. Okay, so. Okay, here we go. So, disease that causes overproduction of dopamine translates to the reduction of dopamine receptors causing downregulation. So when you think up and down regulation, think of what's occurring post-synapse. So post-synapse, there's fewer receptor sites, it's downregulation. If there's more synapses, it's upregulation. So in Parkinson's disease, it is upregulation. All right? Yeah, because there's loss of production of the receptor, of the dopamine, therefore the body's going to respond by increasing the receptor sites. Good? Cool? Cool?
So, that's, I'm gonna remember that thinking about the post, so.
Think post, yeah, when you post down-regulation, fewer, up-regulation, more. And to confuse you even more, the problem with dopamine is that it occurs at the pre-receptor site, that is, it's producing less dopamine, therefore greater more receptors, therefore up-regulation is the concern. Or that's what's happening from a physiological standpoint. Okay. Cool beans? Did I have anything else about, no, actually, probably not, totally, let me see. What is the physiology behind low flu pain, and compare normal to abnormal images? Essentially, it loses its curl over time. Discuss the imaging process, and what problem do you think? In general, just give me a basic idea of how you image. You know, you inject, you image 4 to 5 hours out, and you do SPECT. They want you to do a half-hour scan at 128, which I think is wrong. I think it should be 64, because there's not that many counts, because you're only injecting, I think, 4 or 5, maybe I think it's 5 millicuries by 123. Cool? Comments? Questions? Nay? Say? Quiz on Tuesday? Call me? Text me? Any questions? Cool. It shouldn't be as voluminous as the last exam, I don't think. I don't know. We'll see. But number 7, you know, when I threw in number 7, I said, oh, look at all this extra stuff here. So that's why I decided not to include showings. And, you know, you got plenty of data there. A lot of it's review, but you do need to know it. You know, and we'll see how well you do. Fabulous. Okay. In today's laboratory, let's take a brief look at this. We are going to make MAA. Oh, that's nice. Come on, there we go. We're going to make MAA. We're not going to make sulfur coal with it, unfortunately. And this is the little guy that you're going to be wanting to look at. Okay? So, I will allow one of you